Welcome to Turn Right Machine Works. My name is Keith, and today we have one of those what if type jobs. Customer brings in a through hole and they've got a cutlass bearing, and they said, hey, our press is too small, so they bring it over. So of course, it really sometimes it's not the size of your press that allows you to do some bearings. Sometimes I actually take a bearing like this, put it in a lathe, I chuck up on the OD of the inside sleeve of the through hole, and I spin it, and I come in with a boring bar and cut it out. Well, this length coming in here and sticking out, I can pull my gap and swing this ear, but this sticks out farther than my gap, so I cannot swing this in the lathe. Alright, and the reason why I can't just press the bearing out is because inside here there's a shoulder that you can't actually push against the surface of the end of the bearing, because that shoulder is smaller than the diameter of the bearing. So that only leaves you a couple options, and every once in a while you luck out where this is eaten out from line and all kinds of other stuff that's come in, wrapped around the shaft, chewed up the bearing, and it's gone. Well, there's still part of that bearing sleeve right around in here. And I'm thinking to myself, what if I take a piece of steel plate, cut it to the diameter, clean this all up, take some silicone bronze that I know that it can join hopefully to the sleeve and join to the material, and put a weld bead around there so that you're actually putting a plate solid mounted to the sleeve. Then we'll put this in the press, and my press is big enough to put this in, drop a rod down through here and press the sleeve out. Sounds good in theory, right? Let's go see if we can do it. Alright, we took and we measured this with our spring calipers, and we got about 3 3/4 inch. Now we still got to run a wire wheel through this bore around here and get it nice and clean so that we actually have something good to weld to. The steel is going to go against that rubber that's down in here. So basically we have a section that's probably about that long that this rubber is eaten out of a sleeve like this. So we're actually, and this is a stock bearing right here, and this kind of gives us that diameter too as well. So 3/700 is what I drew on the screen, and we have a piece of 3/8 plate up here on the plasma cam, and we'll give it a little bit of draft here, and grab my hood here real quick. It's about 30 inches a minute. It's not that it's fast or anything, just a dirty piece of steel. But I want a real nice sharp edge, and that's what I'm shooting for. Okay, we'll knock off a little dross there, and this does tap right in there. Okay, we're going to be doing some grinding and cleaning up on the face there, and we're going to be grinding, cleaning up in here, and we do have to go in and get ourselves another cup of coffee, and then we're going to come out and we're going to give a weld bead around there, and after it cools down for a little bit, we will go on into the press, and we're going to try to press this sleeve out. And if we do, then it's kind of the shortcut. It took a little extra steel, and it took a little extra weld bead, but I think the trade-off is for about the hour of machine time that it would take you to go ahead and bore it out, or one other method that it would take to actually get this bearing out of there. Okay, we had to do a little bit of run around here today. One was to go down and get some gas in one of our bottles. The other was to run down and actually measure the shaft that this slides over because there's a concern about the wear on the shaft. So I just got back from doing that. I dressed up this plate here, and we're getting ready to drop it in here, just like that. You're gonna let it sit right on that rubber. We're gonna turn on my vent fan here, so because I know that I'm gonna generate enough heat. Once I start welding on here, I'm gonna be generating enough heat to burn that rubber. So, and I'm gonna go ahead and tack on one side, tack on another side, and then I'm gonna start welding it. Now I'm gonna use silicone bronze, and I happen to have a couple pieces. My inventory is, well, I definitely have enough to do the job, but I have a couple sticks here of a nice heavy thickness. All right, this is silicone bronze. And silicone bronze is one of the best rods I find that doing brazing on steel, or brazing of brass to bronze and bronze to other bronzes, manganese bronze, you know, a lot of different bronzes. This shell on here, I think I've welded on this before, and I think this is low fuming, but I might be wrong. I might actually be fighting a fuming application as well. But I'll still concentrate the heat onto the silicone bronze, onto the steel, and then flood it over to the bronze side or the fuming side of the material. If it just happens to flow like butter, then hunky-dory, and we're gonna have a better weld put on here. Can we give enough weld bead to hold this cap, to turn this thing upside down and drop a big rod in there and press this bearing out? Don't know yet. All right, let's find out. I'm just running argon. I've got 3/32 electrode here. Okay, it wants to fume a little bit. It's drawn some heat. It's gonna take some heat to as I'm down on the steel and then going up to the side, it wants to fume, but it is joining. Okay, so we're going to go ahead and we're going to continue on around. I think I'll stagger it back and forth. Okay, I'm going to work my way around on this, and then I'll bring you in for some shots of it after I've got it completed. Okay, now I brought you in here. I haven't wire brushed this or anything yet. I'll stick that in there in a minute. But I was working over here. Working over here is my two starting spots there, and then I kind of just went 50-50 around. I concentrated my puddle on the bronze. Now you can see that it's pulling and it's juicing out all the way around this bearing on the outside shell, and that's a good thing. That's showing me that I drew it in some. Weld around inside a bore is going to make it draw in or get smaller, so that's going to help for a certain length here. I concentrated that bead on the bronze so that the plate would be pushing against a lip that's more so solid to the bronze itself. I don't really care if that steel plate sticks to the bronze. I mean, good if it does, you know, so what if it doesn't? Because there's enough weld built around here to act like the shell itself that I'm pushing against. And now that I'm going to set it up and I'm actually going to be supporting out here in the hydraulic press and pushing against the inside piece right there, you know, let's hope that this nothing became brittle. It has enough strength to hold there and handle the pushing out to draw the sleeve out of here without any effort, or minimum effort, let's say. All right, you want to see what my wall looks like then in there? All right, let's go ahead and we'll take kind of wire brush this one side here so that you can see that. Okay, we're getting ready. We got this upside down. This bearing I slid through the center ring here, so as long as we make sure that we are equal on this ring right here from this outside right here, 2650 looks like our dimension to go for. That looks pretty good. All right, now we need to go ahead and get a rod to go down in here that we can press on. This will go down in here, but we need to have something a little bit longer because as we're coming down, we know that this will run short of this ring down here a little bit before the travel is full. All right. I'm also glancing over there on my mill just to make sure that my cut, when my cut ends over there, I gotta change directions and get it going. So kind of playing a couple things at the same time here. All right. That looks like a substantial pusher. And we might be able to put right down in here. And we'll move the ram up out of our way here. About this far down from the top in there. That should be more than adequate. I can hear my kite getting close to the end over there. Okay, we're going to grab our flashlight and we're going to look underneath to make sure that we're looking up through and we see that ring of the bearing. Going the other direction now. All right, let's see what we got here. Okay, it does look like it needs to go over this way just a skosh. Back that way just a tiny bit. All right, let's go over there. We'll see what she does. I'm gonna put a catcher down here. I love my press. All right. we'll set this up. Get ready to press in the new sleeve. Okay, here is the old sleeve. And you would have really played heck on trying to get that pressed out, even if you could get something on that back side. Okay, it was pretty cool that we were able to do this so far without interrupting all of our regular projects here. We got gear and a couple other things we're making here. All right, we don't really need this slug up here. But we may need that slug. All right, we lift our ring down. Now, this slips down into the center of our table because we made a bigger cutout on our table. Now we're able to go ahead and take our bearing and put it up there like that. We're going to take this ring here, and we have another little flat dish here. That'll let us push against that and bring it on in. We already held this next to the other one there, and the length is the same. It'll probably cock a little bit. There it goes. We ended up exchanging this bearing or changing out this bearing without having to do any machine work and have any difficulties with our press or anything else. Now, even if this didn't have a blind section in the bottom where we couldn't get to that outside ring, this didn't have enough of the outside ring to press against anyway. It would have just crumbled and you would have been fighting the level of a pusher and everything else in there. This was tapered up on this end here and you wouldn't have been able to push it that way. So by us just doing a quick cutout on the plasma cam, drop a steel plate in there, put a weld bead around there, you heard it come out. It's a good press fit. This was in there, but it's I wouldn't say simple way, but it's another way to get her done.